This is Learning Assessment Problem 3.9. In this problem, we're requested to use nodal analysis to find a current I sub O in the circuit. Since this is a nodal analysis problem, we'll be first obtaining values for node voltages and then using an auxiliary equation to determine the current I sub O being equal to the node voltage V3 divided by 2K. We have 5 nodes in this circuit, and there are 3 voltage sources in the circuit. So this implies that we really only have to solve for one unknown node voltage. We have constraints on those voltage sources, and that would be that V1 is equal to 6 volts, V4 is equal to minus 4 volts, and then we have a floating voltage source V3 minus V2 is equal to 12 volts, and we can rewrite that as V2 is equal to V3 minus 12 volts. We'll be applying the relationship for a supernode in writing our appropriate KCL type equation. This is the supernode with that floating voltage source. We'll label currents positive flowing away from that supernode surface. So we have 4 elements there connected to the supernode, so we'll want to sum those currents to determine the appropriate Kirchhoff's current law equation. So we have KCL at the supernode, and we have a V2 minus V1 for our branch current, but we see that V1 is equal to 6 volts. So that's V2 minus 6 volts divided by 2K plus V2 divided by 1K. That takes care of the 2 currents at the left end of the supernode. And then at the right end we have plus V3 minus V4, but we see that V4 is minus 4 volts. This becomes a plus 4 volts here. And that's divided by 2K. And then the downward flowing current is V3 divided by 2K. And that sum should be 0. So we can rearrange some terms here, and we have 1 over 2K plus 1 over 1K times V2 plus 1 over 2K plus 1 over 2K times V3 is equal to 6 volts divided by 2K minus 4 volts divided by 2K, which is equal to 1 milliamp. So we have 1.5 K to the minus 1 reciprocal kiloohms times so we have 1.5 K to the minus 1 V2 plus 1 K to the minus 1 V3 is equal to 1 milliamp. Now we'll use our node voltage relationship for that supernode and substitute that V2 is V3 minus 12 volts plus 1K to the minus 1 V3 is equal to 1 milliamp. And we now have that 2.5 K to the minus 1 V3 is equal to 19 milliamps. can solve that for V3 equals 7.60 volts. And now we're ready to determine the desired current, I sub O. I sub O is equal to V3 divided by 2K, which would be 7.60 volts divided by 2K, or I sub O is equal to 3.8 milliamps.